Hello, everyone. Welcome. Welcome to Transforming Cloud Operations and Management with Gemini. I need a clicker, and that's right here. I'm Deepak Kallakuri. I lead product for Gemini Cloud Assist. Joining me is my colleague, Mark Church, who's also on the product team. I'm thrilled that Scott Replit from Replit, who leads engineering for Replit, is here and willing to share his perspectives on their customer needs and how we both partner together across engineering to build a great product for our joint customers. Let's take a look at the reality. You probably have seen different versions of this slide. I'll have my own spin on it from a cloud operations standpoint. The reality on the ground is that there's an enormous amount of software being produced because generative AI and agents have made it really easy and reduced the barrier to software development. So a lot of custom applications being built, more builders, more software. That's fantastic for innovation. The flip side of that is the operators are caught up in trying to manage them, ensure they're secure and ready for enterprise deployments. And that's where they're seeing the squeeze. They have to deal with a rapidly evolving set of applications and the software that's being produced. The third issue with this whole thing is that the nature of the applications being produced is not the same as the traditional software. It's not software on steroids. It's actually a different kind of an application with its own unique challenges, such as the quality of the agents, the tracing of the agents, the type of hardware the agents run on. So these are all different. Traditional playbooks are not built for this. And that's where Cloud Assist comes in. The hard truth, though, is we cannot hire our way out of this. Maybe there's a different version of this slide as well, because we all share the same philosophy that we're seeing an increase in dev and ops, and especially the ops budget is going to keep increasing exponentially with the amount of software that's being produced. So the traditional playbooks have to change. And to reclaim that budget, they need to bend the curve. They can't hire their way out of it. So that's where we think Cloud Assist has a place and help the operator teams move into a more autonomous way of operating these new agentic applications. But there's few roadblocks on the way. One, agents need context. As any of you who's developed an agentic application, even it's on Cursor or Claude, you would have noticed that agents without context are just LLM wrappers. So when you think about a team thinking about, hey, let me just build my own agentic application to take care of everything else that's being spun up, what they forget is that it's not an LLM wrapper. They need to actually care and feed for it. They need to ensure it has the right context. They need to ensure that the quality of the app that they build to manage these operations is top-notch, because they have to hill climb on the same app that they're managing these operations for. And that's the reason I think I've seen a lot of crowd today at one of the expo sessions on eval hill climbing. So for those of you who are there, they know the challenge of quality hill climbing on an agent. So that's something a lot of teams immediately forget when they build their first application or an agent that helps deal with these operations. Then there's the whole cost of managing this agentic application that's built to manage operations. Tokens are expensive, especially as you keep running deep troubleshooting and investigations. You'll end up using a lot of tokens. And that's where, again, the maturity curve of building an application comes in, because you have to figure out what is the right amount of context that needs to go into troubleshooting something or managing an operation or designing an application, and ensure it's efficient in what it does. So token efficiency is a key part of this. And finally, there's governance. The governance around what the agent can do, because these agents are really powerful. So once you build them, a lot of operators today act as gatekeepers for developers. And when they try to shift left, the issue was that it just ended up in being more meetings with the dev teams. A couple of teams I met this week, actually today and yesterday, they were telling me the way they operate with their dev teams is that they have to get into meetings and they want to shift more left. But there wasn't a vehicle to do that effectively. And they're all looking at how the agentic applications can help them do that. There's various flavors of SRE agents, for example, which help with that. But the main idea is that Gemini Cloud Assist can be the vehicle for you to shift left and move to a more of a place where the operators are not gatekeepers, but rather enabling an agent-based governance for the applications that the dev teams are building and get out of the way. So the big idea here is that if you have to solve these challenges, we need something more than a smarter search bar. You go to Google Cloud Console, you get a search bar, it helps you get your links, but that's not what's going to cut it. The future requires specialized, enterprise-grade, workflow-driven agents that can automate the heavy lifting of cloud operations, but they always operate under your control and governance. We think, as a team, that's what the future is, getting into a more autonomous state, governed with your control to help you shift left in terms of operations, because a lot of problems that operators see can probably be enforced with better practices right when the development happens. To make that idea a reality, we've launched our new Cloud Assist. It's specialized for your workflows. It's proactive in finding issues, such as troubleshooting or cost anomalies, and it's entirely controlled by your IAM policies. So it doesn't do something that you don't want the agent to do. This update shifts Cloud Assist from manual workflows and your workflows from being a manual, human-driven workflow to a proactive cloud lifecycle management experience. What enables this is an agentic architecture under the Cloud Assist by embedding the Gemini intelligence and the context and the enterprise context you have for your projects and your resources into the operational layer. We've built Cloud Assist in a way that it doesn't require you to manually go and set up something for you to be able to get to a root cause and a remediation plan. For years, we've told everybody to shift left, but move earlier into the development lifecycle. This is the vehicle that we think it'll help the developers get out of the way of the operators and otherwise. A quick glossary of the features we launched. At the center of all of Cloud Assist is a core orchestrator. That's an intelligent orchestrator that first looks at the user query, the prompt, or a proactive alert that comes in and decides if it's complex and needs to be handed off to a specialized agent. And once that happens, it's trying to get out of the way of being the master of all, and it's trying to actually delegate to a specialized agent. This is powered by A2A APIs and MCP tools, so you can access it anywhere you are. That's one of the things that's new as well. And as I mentioned, there's 4 pillars of capabilities we've added to the new set of launches. One, you have the design-based deployment. In here, you would have capabilities such as understanding your own Terraform modules, your custom modules, and your CI/CD workflows when Cloud Assist generates those infrastructure for the applications that you seek for. We've added the ability for Cloud Assist to perform operations such as provisioning or mutating resources with your permissions and human in the loop. We've added a whole bunch of capabilities into investigations, and we've written it ground up for troubleshooting purposes. Mark's going to do a fantastic demo of all the deep troubleshooting that you can do with Cloud Assist. A good example of that is we've added the ability with expert domain agents, such as a database agent, which can help troubleshoot latency performance issues. That's a new addition. So that's an entirely new class of troubleshooting issues that we've unlocked. And finally, we've added cost analysis and optimization agents. A lot of teams spend on a monthly basis, I don't know, probably 3 days. I've seen it with some of the enterprises that I've been speaking to pull a list of all the transactions that happen and analyze the what and the why, and why the BigQuery bill spiked last month and what happened, et cetera. Now you have the power of that in 2 minutes. You ask the agent something, or proactively it's going to tell you, this is why your budget, or you're at risk of increasing your budget, and this is what led to that at a granular level. All of this is built on the Gemini Enterprise platform, some of which you have seen in the keynote this morning, such as the agent registry, the agent identity that you can use to govern the permissions for the agent. And it's already delivering immense value in the real world. A lot of these features are in public preview, so you should be able to access on your console or plug into your MCP tools. Oscar at Petco has already seen a 60% reduction in the amount of time they spend on answering GCP-related questions for their teams. Imagine giving your senior cloud engineers like 3 out of their working days back so they can focus on actually delivering complex architecture rather than the routine triage of issues. Looking under the hood for the anatomy of the agent, I'd call out 3 specific things that we've added. One, there is a dynamic reasoning loop that reasons about the user prompt or the problem or the goal that it is going after and makes tool calls, adjusts the tool calls based on the information received from the previous call. And it does all of that through these reasoning loops. It can run multiple reasoning loops in parallel if needed for complex, deep troubleshooting issues. Then there is a second layer of session and memory and management. So it understands the user's session. It gets the context from the console page and the project and the resources. So based on the necessity of the problem it is trying to solve, it can reason about and get that information from the project. We'll show some of that today. And then we're evolving into a long-term memory where the user sessions are stored and the agent learns over time for the various details such as the environment, the user preferences, et cetera, so it can answer the responses better. All of this you can enhance further with the custom instructions as a feature, yet again another feature that we launched now with this new launch, where you can guide the agent further for your business logic. Things such as I prefer to run on a Cloud SQL in this region, for example. So when it makes recommendations, it knows what your preferences are. I touched upon proactive earlier in the slide. One of the most exciting capabilities that we're very happy with Cloud Assist is the proactive nature that we've announced right now. Operations, as you know and you prefer, shouldn't be reactive, and you want to shift left even as soon as an alert comes. With the proactive capabilities of Cloud Assist, once you set it up with a two-step process, you enable proactive capabilities in the settings for the project. You can pick the alerts that you want to monitor and turn on proactive agents for them. Once you enable these capabilities, the agent would identify groups of alerts, seemingly unrelated, group them together, triage them, decide if an investigation needs to be run, runs it, and follows the alert nature as it evolves over time, triggers another investigation if needed at a later point of time. So you always have the latest information. So by the time if you have to wake up at 3 o'clock and go to your Slack because there's an alert, a remediation possibility as well as the potential other root causes would be available for you right there. Similarly for cost anomaly and analysis. Again, I'd like to stress the fact that all of this runs on top of agent platform capabilities, which means it's audit logged. You can see the logs for what the agent did. It's governed by the agent identity. And it's available in other places. You can consume it through the event arc notifications if you want to integrate into your own pipeline. So let me do a quick demo. Let's switch to the demo, please. Awesome. So what I'm showing here is the new Cloud Assist. And I'm in App Hub. I have an application, which is a chat-based application. And I want to simulate a holiday sale that's coming up. And we want to take you through the entire journey. So what you'll see in the demo today is simulating a high traffic situation, understanding what we can do with it, and then doing a deep troubleshooting of that, and then seeing the cost impact of that particular thing. So you get to see what planning for an application might look like. So let's go ahead and hit that. Now, this is a complex application because, or a prompt to the agent because it's first, I didn't give it a whole lot. All I said was, this is a chat-based app. I want you to add a traffic generator for it. So it's reasoning about, as you can see the thinking, one of the features I mentioned, the thinking and the streaming of the steps. It's looking at the project, trying to figure out the resources. And then it's going to come up with, like, OK, how do I add a traffic generator? It's going to take a minute or so. So let's switch back to the slide, cover that, and come back. Hopefully, it should be ready by then. So there's 3 things, as I mentioned. With the resource design and the application design, we've added the ability to take natural language, produce gcloud, kubectl, or Terraform commands. The agent understands the existing state of the resources, as I mentioned. If there are other traffic generator VMs in the same project, I could have asked for it, and I tested it. It's like, yeah, you got 3 other things because you've been practicing your demo. Like, let's delete the other 2. And the third one is it's governed by the permissions that I have. So if you were to go in and try to do the same thing, if you don't have the permissions, it wouldn't work for you. These capabilities are additive to the application design center as well. And what we've added there are, again, a couple of new capabilities, as I mentioned. You can bring your own Terraform modules. A lot of us, from a customer standpoint, we've been talking to, have been asking about bringing their own Terraform modules because enterprises use custom Terraform modules. So now it's possible. and you can integrate into your existing CI/CD pipeline as well. Further, we've added more to our secure by design principles. Now the design agent, again under the Cloud Assist, it's going to look at the organizational policies, and when it generates the infrastructure design, it's going to take that into consideration and give you the right set of permissions and the resources for it. Also comes up with its own MCP tool, so you can use it in your IDE or Gemini CLI. There should be a session this week if you want to catch up on that. And finally, all of these actions would be approved by humans. So let's go back to the demo and take a quick look and come back to this. So, oh, there we go. So as I said, it has looked at the VM profile, and it's going to create one for it. I hit run. It's working with my credentials. Because it's going to take like 10, 15 seconds, hopefully it should be done. We could come back to this in a second. What I've done here is I've just before this session, I asked it to validate if there was a traffic generator running in this one. Now we could do the same thing. This one's, again, takes about 30 seconds or so, so we can ask for that. So let's go back here. All right. It says there's already one. Like I said, there's one I didn't delete. So it's like, you already have a load generator. Do you want to run one more? Why? So I'm like, all right, let's forget it. It's like, should I update it? Should I create a new one? So this is the power of context. So it's just not going to repeat unnecessary actions. Let's go back to this one. So we got a traffic generator running. To save time, what I've done is I've already asked it to see, can you show me the traffic latency and the error levels for this application, foobar, in this case, Chatly. And it's done all of this work. And you can see it's looked up the traffic, the latency. This is coming from the application topology and G-Cloud and the various tools that we have access to. So the agent's able to pull all of that, the error rate, and it's comprehensive. And now you can actually see it understands the capabilities of what we can do. And it's asking me should I run a deep investigation for you? It looks like you're in trouble. Let's go back to the slide for a second. So thank you. So these agent actions, as I mentioned, available anywhere you want. And you will get a guided step for remediations as well. You'll see that. You saw some of that in my screen, like the security remediation findings as well out in preview soon. All of these actions are audit logged. Let's hear from Mark for how he's going to troubleshoot this complex stuff.
Thank you, Deepak. So Deepak walked us through a lot of quick tasks that you can do in a highly interactive agent. And that's where you have a very responsive agent that can act quick and be dynamic within your workflow. And this really augments your existing workflow. Long-running agents, on the other hand, do much deeper and more comprehensive work. They can run for a longer time, a shorter amount of time, but in any case, they are running until the task is complete. And the evolution of long-running agents are proactive agents. And these are agents that are triggered based on definitions built by you, and they run without human sitting at the keyboard. And really, long-running and proactive agents, they don't just augment your workflows, they change your workflows and the way that your team works. In fact, we've really even seen it in our own team. The way we use these agents has changed significantly in the way we work. And finally, these all pave the way towards the future that we're building next, which are autonomous agents. Autonomous agents that can do processing and evaluate your project and data without you having to define the specific parameters for how and when they run, but all within a safe set of guardrails that are defined by you. So let's go over to the demo, because I want to show you long-running and proactive agents in action. And so what we have here is, I'm actually going to make this a little bit bigger for the people in the back. And what we have is a very similar application that Deepak was just troubleshooting. And I've also asked it about exactly what's happening here. And I can see it's showing me that I've got 503 errors and some latency. And it's basically providing me a breadcrumb of, do you want to go ahead and investigate to go deeper? And I'm going to take it up on its suggestion, and I'm going to say yes. And so now it's taking some context from my conversation, and it's basically going to show me exactly what it's going to start the investigation with, because the investigation is a resource. It's an artifact that's shareable amongst your team that packages together all the information about a particular troubleshooting session. And we can see it's starting with a single resource here, what it's going to start with. So this looks good to me. I'm going to go ahead and run the investigation. And as this investigation starts, it's going to explore the topology. It's going to find other resources, such as other Cloud Run other Cloud Run components, or other pieces of our stack, like our application code. And just for a second, let's briefly look at the investigation to see it running. And we can see here, it's got basically a summary of what it knows so far. And down below here, it's going to start populating this with the observations. And these are really the insights and the raw data that it's found that it thinks are highly relevant to the specific issue that we're looking at. So let's return to our slides for a minute, because this is going to take a couple minutes to run. OK, great. So while that's happening, I want to talk a little bit about how we've improved investigations over the last year. So we first introduced investigations at the last Next. And over the past year, they've become significantly more performative, with the ability to troubleshoot a huge variety of different situations, like multi-tier applications, multi-regional issues, issues that are intermittent, performance-based issues, issues that have happened in the past, all different categories and slices and dices of things that we've analyzed ourselves to make sure that we can do a large breadth of different troubleshooting scenarios. So let's talk about some of the specific improvements that we've made. So the first one is parallelization and statefulness. And so this means that the investigation is able to investigate multiple potential root cause hypotheses in parallel. It will build up an understanding of your environment first, and then it will try to validate or invalidate potential root cause hypotheses as it goes down. So this speeds up its processing. It also enables it to have a wider search scope. The other part is statefulness, in which the investigation is building up a context over time about its plan, what it's found so far, your topology. So it has this internal and stateful representation of everything it knows about that it builds upon incrementally. And investigations have also become multi-turn and interactive. And this means that I can iterate with an investigation. I can add new information. I can steer it in a different direction, run it again. The observations are going to incrementally build on previous ones as I interact with the investigation. And actionable remediations are something we also just added. Based on the root cause, it can provide a specific set of remediations for me to address it that I can authorize Gemini Cloud Assist to execute on my behalf. Investigations can also be run proactively, which we're going to show you in a minute, as they're triggered by cloud alerts. And lastly, we are continuing to expand the data sources that GCA has access to. And one of the ones that I'm most excited about is application code troubleshooting, where in this case, we support Cloud Run application troubleshooting through Cloud Source Deploy, in which the investigation has access to your application code, and it can combine that with infrastructure signals to have a wider scope of the issue. So before we go back to the investigation, I just want to talk a little bit about the specific issue we're troubleshooting. So in this environment, we have a 3-tier app. There's some Cloud Run components. There's a Cloud SQL database in the back end for persistence. And then there's app code that we've deployed through Source Deploy. So we've injected multiple issues in this environment. But the largest one is that the application is written in an inefficient way in which it's going to balloon the memory beyond what the Cloud Run service is actually configured for, causing some faults. And so why is this significant? Well, this is a runtime issue. And this kind of issue might not be caught in your tests or in your build pipeline. It also benefits from bringing the application code together with the infrastructural signals so that it can have a wider picture of the story and what's happening. So let's head back to our investigation now. OK, so this is good. We can see that it has finished its processing. It has already listed one root cause hypothesis here where it says, an application memory exhausted. But let's look at some of the specific observations that justify this. So already we can see here it is referencing a specific snippet of our application source code where it thinks it's triggering the issue. And in this case, we can see it looks like it's finding an inefficient processing loop that creates a 1.5 million dictionary objects. And clearly that must be somewhat related to an OOM. Let's go beyond and kind of see what else it's looking at. We can see high utilization of CPU metrics. We can see specific 503 errors coming from our load balancer. It looks like it's looking at the configuration of our Cloud SQL instance, which in some cases it also tells us what's healthy to tell us what not to focus on. And it looks like it's also finding out-of-memory messages in the logs. So it's found several things to justify this root cause. Now I'm going to go back and actually dive deep into this root cause, because what it's providing here is also a narrative of its understanding of the sequence events that led to this issue. In addition to that, it's providing remediation steps. And so let's go ahead and generate a plan here. Now what's going to happen is that this is going to be generating a specific set of remediations that could potentially address this issue. And so it is suggesting here, would you like me to proceed with increasing the memory? Yes, increase the memory. By the way, these demos end up a little bit different every single time. So that's one of the challenges with generative demos. So let's see here. So in this case, it's actually going to be looking at the configuration of the environment and saying, OK, what is configured right now, so that whatever remediation command it provides is in the context of what's already deployed. And in this case, we can see it's providing a command to increase the memory to 2 gigs. Because that is probably the high water mark, or above the high water mark for what it saw in the memory consumption from the investigation. I'm going to go ahead and run it. Now, Deepak touched on this a little bit, but something I also want to add is that GCA is not going to be making any mutations in your environment without explicit human approval. And that's further gated by the IAM permissions of the user or the agent, and that's further gated by the administrative ability to enable or disable action execution at the global level. And so you can effectively make GCA a read-only agent by disabling this. OK, so this is great. It looks like it ran successfully, and it updated our Cloud Run service, which probably rolled out now. And so this has now solved the issue. And it's also addressed it faster than I can go to my developers and tell them to fix the code. So we've gotten ourselves out of pickle in a very quick way by relying on this. OK, so now I want to talk a little bit about the proactive investigations. So we talked, what we have is we actually have a proactive investigation that we ran to troubleshoot the exact same issue. And first, let me show you how we set it up. So we have a cloud alerting policy that we set up that's looking at the latency for this application. Clearly, we can see that the application is higher than the threshold that we have configured. So I'm going to go ahead and show you how I've configured the proactive agent. So here we can see I've enabled proactive agents. And what this is going to allow us to do is it's going to enable an investigation to be triggered when the alert fires. But it's going to intelligently deduplicate any fired alerts, so it's only going to fire at most once a day for the same kind of issue. And we can look at the specific investigation that got created. So we can see here this was created by an agent. And this actually looks like this is what we expected. It came to the same root cause that we got to when we ran the interactive investigation. And then furthermore, I can also share that when it runs interactively, it is also running with an agent identity using the permissions that we grant to it. So this is the principle that was used. And so that's how we can kind of control how proactive agents, the permissions that they're using. OK. And finally, we've made these investigative capabilities available to all our premium support users. And so what this means is that you can actually go ahead and you have the opportunity to create an investigation as you create support cases. And this is important because this actually transfers any of the information gathered by GCA is automatically transferred to the support engineer that takes your case. So you can run this before you take a case or as your engineer is getting assigned. It doesn't waste any time for you. There's almost no reason not to do it. And you're not going to be repeating yourself, and you're not going to be having to share any new information and you put yourself ahead. So that's one really nice thing. OK, so let's go back to the slides for a moment. So the best part comes when you can automate this whole process using agentic interfaces. We know that everybody here is building and running your own agents. Now imagine that you can take everything we just did and use your own agent to trigger an investigation, see what the result is, and then allow your agent to take the next best action. Well, we're very happy to announce that we're now supporting MCP support for Gemini Cloud Assist, enabling you to do everything we just showed you through the agents that you own, whether that's Gemini CLI, or Cursor, or Claude Code, or your own custom agents. So that means that you can have your agents and tools interact with Gemini Cloud Assist agents to offload some part of your workflow that you might not want to build and eval yourself. And this is very powerful. And so it's very easy. So let's actually go back to the demo, and I'll show you how easy it can be. So here I have Gemini CLI running, and I'm just going to show you the MCP tools that I've got configured, because I have the Application Design Center MCP server and the Gemini Cloud Assist MCP server. And I can show you the skills as well. And these skills help guide our client agent in understanding how to use these tools, because often you want to use these tools to orchestrate more complex workflows. And that's where the skills really help to guide the collective path that you're going down. And so let's end with one final prompt. What I want to do is, we've done load testing on this app for a while, but I want to understand the cost components. And so we're going to utilize those aspects here. And so we're going to say, let's see, we've been doing load testing on the Chatly app. Can you break down the cost components of this load testing for me? And so what this is going to do is this is going to invoke, we've seen this, I think it used the wrong project. So it's going to invoke the Cloud Assist agent, and we're covered. It's going to go invoke the Cloud Assist agent for a specific tool that's focused on cost analysis. And so the way that this does and analyzes it is this helps us actually connect operational events and data with cost data. For example, if resources have scaled up or new resources have deployed, those are operational events. But how do I connect that to cost data to understand exactly how that cost happened? What operational events led to what specific cost changes? We'll let that run for a second as it's generating our cost report. And I just want to summarize all the things that we've gone over. So we have covered so much. And honestly, I don't think we've seen everything yet. So we've covered more dynamic and contextualized chat, the ability to design and deploy interactively, more parallelized and powerful investigations, new data sources like application code, the ability to understand costs and its relationships with operational events, and the ability to access all of this through MCP. And so now let's go back to here, and it's probably, it's doing its thing. But what it's going to do right now is it's probably looking at all the events that have occurred, what has been deployed, and here we go. Here's our cost report. Great, so it's broken down the components of the application. It's telling us the cost. And of course, if we wanted to go deeper, and if we wanted to find out, OK, what is the change over time? What are the trends? We could do all that as well and continue to go deeper with the agent. OK, let's go back to the slides. OK, so some of the things we talked about today are still in private preview. And so we encourage you to work with your account teams to get access. And now that we've showed you all this cool stuff, let's actually get a real customer out here to talk to you about it as well. So I want to go ahead and introduce Scott Kennedy, VP of Engineering at Replit.
Right. Thanks, Mark.
Thank you, Scott. There you go.
Hey, everybody. I'm Scott from Replit. If you don't know what Replit is, Replit's the leading vibe coding platform for knowledge workers. I say knowledge workers because about 80% of the users building apps on Replit are not software engineers. And so they're sort of building for the first time. We're unleashing all this new creativity. For a quick idea of how it works, you can come to Replit and put in a prompt of an app you want. We will, in parallel, build your front end and your back end. We'll provision you a database. We'll set up auth. We'll get you AI inference if you need it. All those things that get you sort of that wow moment of your app running. So say you need a partner portal for this week because you're running a booth at Cloud Next. We could do that for you. And then once you're happy with it, with a single click, you can publish that app, and we will provision you a Cloud Run instance. We will get it up and running on the internet with a URL, and so you can have a real live application in just minutes. Now, our users tend to go much further than this. This is a good example of what it might look like for a brand new user, but they continue to prompt, they add new features, and for some of them, they end up creating a business or running something pretty powerful. And so Deepak was saying, we've got more code, more builders. I think when you stack those on top of each other, you get exponentially more code. This is a graph of live published applications on Replit. We recently crossed 1 million. It's now about 1.2 million active applications. And so for those users who I think are really succeeding, their idea has come to life. They could never hire an engineering team before, or they hired the wrong one. Something didn't work before, but working with Replit got them there. They now fall into some traps of success. As an AI engineering team, we're actually not doing the whole job because, like we were pointing out earlier, OpEx ends up being a lot of the part of an app that succeeds. They start to hit the common problems we've seen before. They don't understand the bill or the costs. Maybe you've done something silly like a long-running request on serverless compute. They start asking questions about reliability. They get reports from users about something being down, and they're not quite sure how to troubleshoot. They don't have that on-caller yet. Tuning the resources feels like sort of a mysterious art to them. How much CPU, how much RAM, it's hard to say. And security ends up being very anxiety-inducing. There's the treadmill of CVEs being revealed. You never know what's secure, and they're always looking for more assurance there. So what is the solution here to this problem? It's actually more AI. It's things like Cloud Assist. We think the models are now in a place where they can hold the full software development lifecycle. We can really be your AI engineering team and be on call and be the security engineer and proactively patching. So I'm giving you a little sneak preview of something that we're releasing next week on Tuesday, which is just simple uptime monitoring with the ability to investigate right on the platform. And when you click that, it uses under the covers Cloud Assist and other tools, and so it can go in and investigate the source of those downtimes. In this case, it found that it's, like earlier, it's a memory issue, and because we have the full context of the code base and how Replit works, in addition to the agent that understands Google Cloud very deeply, we can come up with the right prescription, and then with one click allow you to confirm and apply the changes, and then you can redeploy. I think we're going somewhere very exciting where this can be completely autonomous. Costs could be auto-optimized. CVEs could be auto-patched and deployed. I might never have to think about responding to a CVE notice again. My agent will just have it patched, and it can tell me if I was ever vulnerable and if I should take any actions. And the AIs will be the first-line on-caller. I'm not going to be tier 1 on-call ever again. An AI is going to handle it. It's going to take those, and it's only going to escalate to me when it's necessary. And so I'm really excited where we can go together with teams like Cloud Assist and where the industry is going. I think we're really just at the tip of this. Back to you, Mark.
Questions? We got a few minutes, so shoot away. Yes.
Here comes the mic.
We can replay the question. I think you're asking about when will Cloud Assist work across multiple projects?
Because it needs to understand the context behind the group of resources placed under multiple projects.
I was expecting this question, of course. This is probably one of the top 2 questions that we get. We are working on it. We know it's one of the most important things, and there's like so many applications and infrastructures cross project boundaries. And so we want to provide the right UX and the right primitives to be able to kind of specify which projects you're looking at. Obviously, there's some challenges, like customers might be in a massive org, and they want to say, like, which VMs is this vulnerability across, and that org has 100,000 VMs, right? And so like, how do you process a request like that? But I think that is absolutely solvable and is #1 thing on our list to really complete after next. And I think I've said that 100 times internally, so I really mean it.
Yes.
Here comes the mic.
In your example, when you asked Cloud Assist to deploy an Nginx workload to your cluster, usually Cloud Assist or Cloud Shell doesn't have direct network connectivity to your VPC. How does that work with Cloud Assist?
Well, in this case, that Nginx that was deployed wasn't talking to Cloud Assist, right? Mm-hmm. So like that traffic generator was deployed into the VPC, talking to another element in the VPC. Gemini Cloud Assist is really talking to the GCP control plane, right? So like Gemini Cloud Assist is not sending packets in the VPC. It doesn't have access, but it has access to Google APIs to deploy and update things.
It's acting on your behalf. That's the main takeaway. Any more questions? Oh, yes, someone
there. Are you planning to connect to GitHub with Cloud Assist?
Yes. So we almost launched that for Next. We were very close to. So we were kind of had some parallel tracks working with the Cloud Run team to do application code troubleshooting for that. But also kind of immediately after Next, we really want to focus on supporting other repositories through another product in GCP called DevConnect. So yes. Yeah.
Cloud patterns or architecture patterns? Can it be customized to your business?
So we showed a little bit of a glimpse for that. There's 2 key areas that we want to go in. One which we've already launched, which is custom instructions. So you can put a lot in there. It's limited by 3,000 characters or so now at this point, but we plan to expand it. The idea being you are able to give your business logic in there for the agent to use as additional context when it tries to answer a prompt or trigger troubleshooting or design an application. So you can define that. On the roadmap, we are looking at the ability to pull from sources such as Confluence or Git, because we are seeing a lot of customers these days have started to move from Confluence to Git for putting their playbooks or best practices. So again, the Git connection for both source code as well as instructions or playbooks as a data source is what we're looking at.
Any other questions? This man, right here.
So we are using Terraform and Terraform Cloud with Azure DevOps, and we build our own Terraform modules. How am I linking Cloud Assist into my repos to make sure that I'm following the same patterns if I'm troubleshooting something with whatever I'm deploying? How am I doing that?
So actually, I have 2 of my favorite PMs right there, Vijay and Ovana. You should catch them right after this.
Okay.
They can tell you all about the best practices.
Okay, perfect. Okay, I don't have my DevOps engineer with me, but I'll link with those guys. Okay, thank you.
Those are the wonderful folks who are building the Bring Your Own Terraform and the Design Center use cases we talked about. Yes, gentleman here up front. Yes, go for it. No, I got time.
Thank you. We just attended a session about the SRE, just before the session.
Yes.
And the SRE orchestration and the army of agents, AI agents. So I'm wondering how the Cloud Assist is going to be embedded in this full picture. Because what it does is literally the same thing you just described here. So I'm confused how the other part is either separate or complement the Cloud Assist. There are 9 agents there just to...
happens to be the product leader for this organization, and we all are building this product as part of this. So whatever you saw as an SRE agent is a, let's imagine the investigation agent we talked about, expanding into a full-blown set of SRE use cases as we relate to the autonomous cloud journeys that we're talking about. That's a framing we are using to look at a rollout, deployment rollout as a problem statement within the SRE workflow, and then setting up monitoring, et cetera. So it feeds right into it. It will be the same product. We are at time, but we can take your questions, and I think in half an hour or so, there's another discussion group.
There's I'm not sure what the name is, but it's O25-DG. There's a discussion group where we have basically a small format room where we can have kind of a bi-directional discussion. We would love to have any of you there and take feedback that we can incorporate in our roadmap. So thank you all so much.
Thanks for coming.